Hi, welcome to Vectors and Scalars Part 4. This will be the video where I'll go through how to use sine, cosine, and tangent when finding the direction of a vector. Okay, so first thing I want to do is remind you that we'll be using right triangles here. Right triangles have a 90-degree angle in one corner. Doesn't matter which one. However, the hypotenuse will always be the side that is the longest side and opposite of the 90-degree angle. So let's think about if this was a vector problem. We've got two vectors here that we're adding together, this vector and this vector, to find the resultant vector here. In this case, it's the hypotenuse. Okay, so if we want to find the direction of the resultant vector, the one right now that we're calling the hypotenuse, one of the things that we're going to need to find is this angle here, which I've chosen to label theta. Theta is a Greek letter that's often used to describe an angle. It's one that I use in class all the time. Your teacher may use a different letter, but that's beside the point. Okay. If the angle theta is where I've positioned it, then that means that the opposite side is going to be this side over here, opposite of the angle theta. Which means then that our adjacent side, adjacent meaning next to, is going to be the side on the bottom because it's next to the angle theta. Okay, this is the angle. Alright, so you should know this by now, but the definitions of sine, cosine, and tangent are fairly easy. The sine of the angle theta is the opposite side divided by the hypotenuse. The mnemonic that we use for that is so. Sine is equal to opposite divided by hypotenuse. Okay. For cosine, the cosine of theta is equal to the adjacent divided by the hypotenuse, ca, C-A-H. And the tangent is going to be the opposite side divided by the adjacent side. Tangent of the angle theta is equal to the opposite divided by the adjacent, toa. Okay, so the mnemonic so, ca, toa. Pretty easy to remember, but they're ones that you're probably going to need to know for your test. So these are good ones to write down. Remember, you can only use sine, cosine, and tangent when you're dealing with right triangles. You can't use them for the acute or the obtuse triangles. They need to have one angle that is 90 degrees. Otherwise, these don't work. Okay, so if we have our hypotenuse, our opposite side, and our adjacent side in this triangle here, and we want to find the angle theta, okay, if we know the two sides, let's say we know the opposite side and the hypotenuse, then what we need to do is get rid of the sign on this side of the equation. Now, just like if you're doing algebra and you want to get rid of something that's multiplying x, you would do the opposite. You'd do division to get rid of that thing that was multiplying x. Okay? In this case, sine is just like multiplication. It's a function, and what we're going to do is get rid of it by doing the inverse sign, the opposite sign. Okay? So the inverse sign, sine to the -1, is going to cancel out this sign right here, leaving us with just theta. Okay, but whatever we do to one side, we have to do to both sides. So notice that I didn't have a negative or an inverse sign over here. So inverse sign on both sides, which is going to get rid of the sign that we had there before, and that'll give us that theta, this angle right here, is equal to the inverse sign of the opposite divided by the hypotenuse. Okay, I'm going to show you this here real quick. This is my TI 89 that I've used for years. I just happen to have a copy of it for my computer. If we turn it on here, you'll see that there are two different buttons here, one for sine and one for inverse sine. Okay. If I wanted to use the inverse sine, I would hit the gray button. Oops, turned off. I would hit the gray button and inverse sine. Okay. If I wanted to instead use the sine button, okay, I would use the second key and hit sine. Now, it's important when you're doing these problems that you use the appropriate type, either sine or inverse sine, for the problem that you're trying to solve. The other thing that I want to remind you is to go into your mode and make sure that your mode is set here. Your angles are set on degrees, not radians. They need to be set on degrees. Okay, so we'll exit out of that. Some of you don't have TIs. You have Casios, I think, are the ones that use arctan or arcsine. So here you'll notice that there's arcsine. This is the same as inverse sine. It's just a different way to say it. Some calculators use arcsine, some calculators use inverse sine. They're the same thing. You just need to know which one your calculator uses so you don't get confused on the test. Alright, so now we're ready to start using this idea here. So if we wanted to find angle theta, and we knew the opposite side and the hypotenuse, we would use the inverse sine function to find that. Okay. If instead we wanted to use the adjacent side and the hypotenuse, we would use the inverse cosine, the adjacent side and the hypotenuse, if those are the two angles that we know. But most of the time you'll be using the inverse tangent function because you'll know the adjacent side and you'll know the opposite side, and you'll be trying to find the hypotenuse and the angle between the hypotenuse. So you'll use the inverse tangent. Again, if we look at our handy dandy calculator here, you'll notice that there's a tangent and an inverse tangent. Make sure that you're using the correct one when you're solving your problems. Okay. So here's a couple of practice problems. The first one that I want you to do is to find angle Z. So go ahead and pause the video now. You can find angle Z and then find angle X, and I will go through how to find both of them when you restart the video. So you should have a solution for your two problems now, finding angle Z and finding angle X. So let's go through how I solve them. Okay. To find angle Z, since I know the hypotenuse and I know the opposite side, okay, if this is angle Z, I know the opposite side, I want to use inverse sine. Okay. So I'll come over here to my calculator and I will take the inverse sine, oops, it's the regular sine, the inverse sine of 156 divided by 217, and I will get an angle of about 46 degrees. Okay, so I'll get rid of this, show you here, get an angle of about 46 degrees. For angle X, since angle X is up here, we know the adjacent side and the hypotenuse, so we're going to want to use the inverse cosine. Okay, again, it's going to be the adjacent side divided by the hypotenuse. Okay, so we want to find the inverse cosine of 156 divided by 217. That'll give you about 44 degrees. Okay, so and then again, just to check your work, remember that a triangle always has 180 degrees on the inside. So if you have 90 degrees here, 46 degrees here, 44 degrees here, should add up to be about 180. By about, I mean within a couple of decimal points. Okay, they work out in this case. Okay, so we're going to go ahead and finish up this portion of the review. One more practice problem. Go ahead and find angles O and M. Pause the video, and once you've got your own solution, go ahead and start it back up and I'll show you my solution. Okay, so you should have your own solution now for angles O and M. So let's go ahead and find angle O. Now note that we have the adjacent side and the opposite side, but we don't have the hypotenuse. You could go through and find the hypotenuse on your own using the Pythagorean theorem, but that's kind of a waste of time for this particular problem. So let's go ahead and just use the inverse tangent, okay? Because remember, inverse tangent uses the opposite side over the adjacent side. So we'll grab our calculator here. As you can see, I've used the inverse tangent of the opposite over the adjacent, which gave me about 51.3 degrees. Okay, 51.3 degrees. Okay, so now we've got to find angle M, this angle down here. So again, we're going to want to use the inverse tangent, except now that our opposite side is the 1016 and the adjacent side is the 1266. So we'll set up our formula. Remember, it's a good idea to write this down so you're not just plugging it into your calculator and making sure that you're doing it the correct way. Okay, if I were to bring my calculator over, clear this out, this will give me the inverse tangent of 1016 divided by 1266, which will give me 38.7, okay, when rounded. Again, notice that 90 plus 51.3 plus 38.7 is 180 degrees. Awesome, I did the equations correctly. Okay, so go ahead and start up the next video. We'll do some actual physics problems using the trig functions, and that'll be the last part of this review.